This is 4.4.5. Finding the exact displacement, and if this is the velocity, it'll be the antiderivative of this evaluated from -1 to 5. So the antiderivative of this would be, so if I raise the 2 to a 3 and divide by 3, it'd be negative 1/3 t to the third. If this is power 1, so raise it by 1, that'd be 2, and divide by 2, so it'd be plus 2t squared. And this is t to the 0, so I raise it by 1 and divide by 1, and I get minus 3t. And I want to evaluate that from -1 to 5. So putting in 5, I get 125 over 3 plus 25 times 2 is 50 minus 15 minus, now I put in -1 into all of this, -1 to the third is -1 times -1/3 is 1/3. -1 squared is 1 times 2 is 2. And -1 times -3 is 3. And I get, see, this would be 35 minus 5 would be 30. And then this would make minus 126 thirds, 126 over 3. This and this is 126 over 3. So that would be, goes in there, 42. So this and this is minus 42, and this, which is 35 minus 5 is 30. So I think I get negative 12 if I didn't make arithmetic error. And now let's check that. So make sure I didn't make an arithmetic error. I'll pull up my calculator and type in negative x squared plus 4x minus 3. Second, calculate 7. And I want to find the area between -1 and 5. And -1 and 5 are on my screen. The graph might be off, but I don't need to see that. So second, calculate. Number 7 is the area between -1 and 5. And there was negative, a little positive, and a negative, and makes a -12 total. And that's what it says. So that's the correct answer. This one. So this 1 over x squared is x to the -2. So the antiderivative, if I add 1 to -2, I get -1, and I divide by -1, so I get negative 1x to the -1, which is the same as -1 over x. And I have to evaluate that between 2 and 4. So if I put in 4, I get -1/4 minus, and if I put in 2, I get -1/2. So that's -1/4 plus 1/2, which is 1/4. Now we can check that one. 1 divided by x squared. Second, calculate the area from let's go zoom 4 first and calculate. Second, calculate the area from 2, enter, to 4, enter. Nope, did the wrong one. Second, calculate area, number 7, between 2, enter, and 4, enter. And it says that's a small area there, and it says it's 0.25, 1/4. All right, this one, evaluate the definite integral from 2 to 9. So the antiderivative of 4x, see that's 1, so we add 1, that's 2, and divide by 2, so it's 2x squared, and 10 goes to 10x from 2 to 9. So I put in 9, and I got 81 times 2, 162, plus 90 minus 4, 2 squared is 4 times 2 is 8, plus 20, so 28, and this is 252 minus 28, which is 224, I believe. Let's check that. Y equals, clear, 4x plus 10, 4x plus 10, and graph. It's way off the screen, but I got to go 2 to 9. 9's not on here, so I'm going to go zoom 6. Still way off the screen. 2 to 9, it's going to be a lot of area. This calculator will still do it. So second, calculate 7 from 2 to 9, and it says it's 224. Number 4. 36 minus x squared. So the antiderivative of 36 is 36x. The antiderivative of x squared is, add 1 to 2, it is 3, so it's 1/3, because you're going to divide by the 3 times x to the third. So it's minus 1/3 x to the third, evaluated from minus 6 to 6. So if I put in 6, I get 216. 6 times 6 times 6 divided by 3 is 2 times 6 times 6. 6 times 6 is 32, times 2 is 72. That's what I get when I put in 6. And when I put in negative 6, I'm going to get negative 216 plus 72. But this minus, a minus will make that plus and plus. So it'll be this answer times 2. And this answer, see, 216 minus 72, that'll be 144. And this will be 144 negative and negative, and so it's 288, I believe. And negative 6 to 6 is on this, so it would just go to here and type in clear 36 minus x squared. And second, calculate, number 7. It really goes up a lot of area from negative 6, enter, to 6, enter, 288. Now, just note, this is an even function. If I put in negative 6 into this and positive 6, I get the same thing. And I can tell that from the graph. It's symmetric with the y-axis. So I didn't have to do both of it. I cut it just from 0 to 6 and doubled my answer. I knew that the area of this side is going to equal the area on that side. Okay, because it's an even function. Okay, simplify the integrand before integrating. So, what they wanted me to do is divide this into each part to make it a little simpler. So this is x to the 1/2 in the denominator, which would be x to the negative 1/2 in the numerator that I have to take times both of these. So if I take x to the negative 1/2 times x squared, I get x to the 2 minus a half, x to the 3/2. So I get 8x to the 3/2 plus 3x to the negative 1/2 and to integrate this, I have to add 1 to 3/2, which is 5/2. So it would be x to the 5/2, and I have to divide by 5/2, which is the same as multiplying by 2/5 times 8, so that's 16/5. That's the antiderivative of that. Plus, adding 1 to negative 1/2 is plus 1/2. So I'll have x to the 1/2, and then I have to divide by a half, which is the same as multiplying by 2 times 3, 6. So this is what I have to evaluate from 3 to 8. Now, 5/2 is 2 1/2, which means it's x squared times the square root of x. So this would be 16/5 times x squared, 8 squared, which is 64, times the square root of 8, which is 2 square roots of 2. So that's 8 to the 5/2. Plus, this would be just the square root of 8, which is 2 square roots of 2 times 6, 12 square roots of 2. There's 8 put in, minus, put 3 in, so 3 squared is 9, times 16, let's see, 10 times 16 is 160, minus 16, 160, 50, 140, 144, 144, over 5. That's 3 squared is 9 times that, times the square root of 3. 3 squared and square root. So 9 times 16, 144 over 5 times the square root of 3. And then I put it in here, and that's plus 6 square roots of 3. That's the exact answer. I could multiply the 16 times 64. Let's figure this out. Make sure I got it right. So second quit, let's get the decimal approximation. So 16 times 64 times 2 square root 2 divided by, divided by 5 plus 12 square root of 2 minus 144 times the square root of 3 divided by 5, and then minus this part, minus 6 square root 3, and we get 535.957. Now let's try it with the calculator and see what it estimates the approximate answer is. So I go to y equals, clear that. If I go alpha, y equals, I'll get that fraction thing, and I can type in 8x squared plus 3 in the numerator, and the denominator square root of x, and we're going from 3 to 8, so zoom 6 should work for the graph. And it's off the screen, but the 3 and 8 are there, so I can go second, calculate the area from 3 to 8, and it tells me it is 535.95707. That's its estimate, and that's what we got from this. This is the exact, the unexact answer, and there's some more simplification that could be done there. Now it says, do the, let me get this up here, the 8 sine x from 0 to pi. Well, we can pull out the 8. The antiderivative of sine is cosine, so it's 8, a negative cosine actually, cosine x evaluated from 0 to pi. And the sine is an odd function. Sine would look like this and like this. When it's got origin, point, symmetry, the area on this side and the area on this side are equal and opposite if you go same distance. But we're only going from 0 to pi, so we're figuring out the area just of this. And it goes 8 high for the sine. Now, if it said from minus pi to pi, I would know the answer is 0 right away. But let's see what this works out to be. So if we put pi in here, cosine of pi, if I go to the unit circle, pi is over here. The x-coordinate is -1, so cosine of pi is -1 times -8 is 8 minus, and if I put in 0, the cosine is, the x-coordinate is 1, 1 times -8 is -8. So 8 minus a -8 is 16. So let's check that. So clear and put in 8 sine x. 8 sine x. And I want to make sure I'm doing this in radians for calculus. Second, calculate 7. The area from the lower limit is 0 and the upper limit is pi. And it says that area is 16. Number 7. So from here to there, it's this equation. Otherwise, it's straight lines, it says, for the velocity of a thing moving in meters per minute. And the first question says, what's the exact distance traveled on the interval from 0 to 4? So that's the area under here. We could estimate it by counting squares, and we could estimate it by typing this into the calculator and going from 0 to 4. But to get the exact, we need to do the antiderivative. So the first thing we do is add 1 to this power, which 3 plus 1 is 4, and divide by 4, so we get -1/16 t to the 4th. Add 1 to this, that would be 3, and divide by 3, so the 3's would cancel, it would be +1/2 t to the 3rd, and 1 would go to 1t. and we have to evaluate from 0 to 4. And 0 into this is 0, so all we have to really do is do 4 into here. And 4 times 4 is 16, which would cancel that, times 4, which is 16. 4 into this is 16. And this would be 4 times 4, 16 times 4 is 64, divided by 2 is plus 32 plus 4. So negative 16 plus 32 is positive 16 plus 4 is 20. So the area here is 20. So that's the exact distance, and that's 20 meters in those 4 minutes. What's the object's average velocity from 12 to 24? 12 to 24. Well, here we can do it just by area. We could write the equation and do the antiderivative, but since these are straight lines, that is a trapezoid. This side of the trapezoid is 9. This side is 15. The average of 9 and 15 is 12. 15 plus 9 is 24, divided by 2 is 12. So the area of the trapezoid is equal to the area of this rectangle. 4 times 12, 48. This is 15 for 4. So 15 times 4 is 60. And then this last one goes from 15 down to 6. 15 plus 6 is 21. Divided by 2, but times 4, so it's just times 2, 42. So the total area here is 90 plus 60, 150. The area is 150. And if we want the average velocity, we take the total change in distance, 150 meters, divided by how much time it happened, which was 12 minutes. And we get an average velocity of 12.5 meters per minute, which graphically means, excuse me, if we were to try to level this all off to one value, it would be 12.5. This would fill in that little corner there and fill in that triangle there and make it a rectangle, 12.5 high for 12. At what time was the object's acceleration greatest? So this is a Calc 1 question. Acceleration is the derivative of velocity. So when is the slope, the derivative, the slope of the graph the steepest? Well, it looks like it might happen right in here, about 2 minutes in. Now suppose, how would we get this area to be 210? Now right now we have 150, so we need 60 more. So to get 60 more, if this is 12, 12 times 5 would make it 60, so we would have to add 5 to the whole graph. We've raised the whole graph by 5. We'd end up with 60 more in this area here. So the amount that we would have to increase, the constant c, would have to be 5 meters per minute. To determine the exact value of, say, this function is piecewise defined here for 0 to 2, this for 2 to 3, this from 3 to 5. Determine the exact value of the net signed area of f on the interval 2 to 5. 2 to 5. So we have to find the area under this from 2 to 3, and the area under this from 3 to 5. This one would be fairly simple. Would be a trapezoid. We could use the trapezoid rule. At 2, it's 1 high, and at 3, it's 0 high. So if it goes from 1 to 0 for 1, that would be a half. 1 to 0, 1 wide, 1 to 0, so that triangle would be a half. Now we could do the antiderivative of this also. This part, the area is 1/2. Let's see. The antiderivative of negative x would be negative 1/2 x squared. Antiderivative of 3 is plus 3x. Evaluated from 2 to 3. Put in 3 and we get 9/2 plus 9. So that's positive 9/2, so 4.5. Then we got to go minus, and then put in 2, and we get 4 divided by 2 is 2, negative 2, and plus 6, so that's 4. So 4/2 minus 4 is 1/2. What we decided was by just using the trapezoidal. Now this is a parabola, so we do need to do the antiderivative. So raising 2 to 3, so this would be 1/3 x to the 3 minus 1 to 2, so we got to divide by 2, so it's minus 4x squared plus 15x evaluated from 3 to 5. So if I put 5 in there, it's 125/3. I put 5 in there, that's 25 times the negative 4 is negative 100. And put 5 in there, and that's plus 75. And then I put 3 in, and that's 27 divided by 3, or 9, minus 9. And 3 in there is 9 times 4 is 36, minus 36. And 3 in there is plus 75. No, plus 45. So, minus 36 plus 45 is 9, and 9 is 18. And this is minus 100 plus 75 is minus 25 plus 18. Minus 25 plus, minus 25 minus 18 is minus 25, 33, 43. So we have minus 43 plus, see, 3 in here is 41 2/3. 41 2/3 minus 43 is minus 1 1/3, minus 4/3. So the area under this is minus 4/3. The area under this is 1/2. So 1/2 from 4/3 will make this 6. 3/6 minus 8/6 is minus 5/6. That's the first one. Compute the exact average value of f on 0 to 5. 0 to 5. So we have to find the area under this one. Okay. So adding to 2, 1 would be 3. So negative 1/3 x to the 3rd plus x squared plus x. Adding 1 to this 2, divide by 2, and gets that x squared, and x evaluated from 0 to 2. 0 is going to give us nothing, so the 2 is the only one we really have to do on this. 8 minus 8 thirds plus 4 plus 2. So this is minus 2 and 2 thirds. So the minus 2 cancels the 2. So we have 4 minus 2 thirds, which is 3 and 1 third. 3 and 1 third for this part. B, it said from 0 to 5, what's the average value? So you have to get the total area. And so it would be the 3 and 1 third minus 1 and a third, which would be 2, plus the half. So it's 2 and a half, or 5 halves, divided by 5, which is 1 half. And that would be the average value. And then on the final part here, C, it says find the formula for this so that at the end of 7, we're at 0. Well, if we're already at 5.5 total, we have to get minus 5.5. So to get minus 5.5, or 5 halves, in an interval of 2, we'd have to get half of this each part. So g of x would have to be half of that, or minus 5/4, or minus 1 1/4. So in the first unit, it would lose 1 1/4. In the second unit, use 1 1/4, which would lose all of the 5.5 we had up till now, and that would get us to 0 by the end of 7. Number 9. When an aircraft attempts to climb rapidly as possible, the climb rate in feet per minute decreases as altitude because there's less air in the air is less dense. So it has a harder time climbing, so it climbs pretty fast at the beginning and gets less and less and less for each 1,000 feet. Let a new function called m of h measures the number of minutes required to climb to a height h. So the number of minutes climbed. So this is the feet per minute. And they want to know minutes to climb a foot. So that's just the reciprocal of these. So the new function m of h would be 1 over 925, 1 over 875, all the way through. And so that's the similar table of values. Be sure to explain the units. So now it's feet per minute for that many minutes. You could change it to decimals, but let's just leave it as a fraction. B, be careful. Give a careful interpretation of the function whose derivative is this. Well, the function would be the total minutes to climb, because this is the change in minutes per foot. So this would be, it would give the total minutes to climb a certain distance. So it's the total minutes for the climb. Determine the definite integral whose value tells exactly the number of minutes. Let's do this. That would be the integral from 0 feet to 10,000 feet of m of h dh. Use the read-months on M5 to estimate the value of this. How many minutes does it take to get to 10,000 feet? So if we're going to do M5, we have to divide this into 5 equal pieces. So if I go from there to there, that's 1. From there to there is 2, 3, 4, 5. And if we use the middle, we got to use this one. So we're going to take to find the area, we take the width of the interval. So that's 1,000 feet times 1 foot for let's see. The width is 1,000, 2,000, 0 to 2,000, and this is minutes per feet. 1 minute per 875 feet. So that would be, the feet would cancel, and we would get the number of minutes to do the first 2,000 feet. Then the next one is still 2,000, and they're all 2,000. So I can take 2,000 times 1 over 875 plus 1 over the middle of this one is 780. 1 over 780 plus the middle of the next one is 1 over 685 plus the middle of the next one is 1 over 585 plus 1 over 490. So I just have to type that into my calculator, take it, find that sum, take it times 2,000. I should know how many minutes it takes to get from 0 to 10,000 feet. The average velocity is change in the distance over the change in the time. So that's what we did in Calc 1, early on, Chapter 1. Take the change in the distance over the change in time, and that gives you the average velocity. Change in s over change in t. Well, this is the change in s. That's what that is. And that's the change in time. So this is doing the same thing as that. And so the question is, are these the same? And the answer is yes, they are the same. And finally, 11. This one, the whole point of this one is, first of all, what's f of x look like? F of x is 1 over x, and 1 over x looks like this, because 1 over 1 is 1, 1 over 2 is a half, 1 over 3 is a third, 1 over a half is 2, 1 over a third is 3, and it looks like that. But it also looks like that on this side. Now, what is the antiderivative of 1 over x? Well, we know that the derivative of ln x is 1 over x. So the slope of ln x, now let's see, ln x looks like this, if you don't remember. So the slope of this is the black line. Notice it's a very steep positive slope here, and that's why this is big. And it gets to 1 about here, where the slope of this tangent line is 1, then it gets less and less slope, and that's what this is saying. Now, over here, it says it's very steep and negative slope, and then it gets less and less, and that's what this would look like, which is the ln reflected over the axis. The equation for this is ln of negative x, and this one is ln of x. So what would be the equation of this whole thing put together? And that's what they're trying to get you to see by talking about ln of absolute value of x. Absolute value of x is negative x when x is less than 0 and positive x. So the whole point of this is the antiderivative of 1 over x is not just ln x for over here, but the ln of absolute value of x for all x's, except 0. Can't do 0 because the function's not defined there. And that's what 11's about.